Hi everyone, I'm going to be going over question number 10.37 from the bingo problems. This problem says find the magnitude of the angular momentum of the second hand on a clock about an axis through the center of the clock face. The clock hand has a length of 15 centimeters and a mass of 6 grams. Take the second hand to be a slender rod rotating with constant angular velocity about one end. So, first of all, I wrote down what's given, and I already converted it to the units we need. So grams to kilograms, centimeters to meters. But now what we need to do is, I guess first of all, find the moment of inertia. And so we know for a rod, it's going to be, the moment of inertia is going to be 1/3 mL squared. And since we know the mass and the length, we can find the moment of inertia quite easily. So we plug that in and we get I equals 1/3 times 6 times 10 to the negative third times 0.15 squared. Throw that into our calculator and we end up getting that the moment of inertia is 4.5 times 10 to the negative fifth kilogram meters squared. I think I'll run, it's already. So I equals 4.5 times 10 to the negative fifth. Okay. But now what we can do, so we know that the magnitude of angular momentum is going to be equal to I times the angular velocity, right? The moment of inertia times the angular velocity. That's the magnitude of angular momentum. And so to find the angular velocity is we know that it's going to be 2 pi in 60 seconds, right? Because the second hand of a clock is going to make 1 revolution, or 2 pi radians, every 60 seconds. So all we need to do now is multiply our moment of inertia by our angular velocity, and we will end up with the magnitude of angular momentum. So when we do that, we get 4.5 times 10 to the negative fifth times 2 pi over 60 seconds. This is radians, this is kilograms meters squared. And when we do that, we end up getting 4.7 times 10 to the negative 6, with our units being kilograms times meters squared per second. So that's it. So just to recap what we did is we first of all had to convert, I know I did that off camera, but convert our values to what we could use in our equations. We used the moment of inertia of a rod to find the moment of inertia, and then we used the equation to find the angular momentum, which is the moment of inertia times the angular velocity, and we ended up with 4.7 times 10 to the negative 6 kilograms times meters squared per second. So that's it. It's a pretty short problem, but I hope you learned some, and I'll see you in the next video. Thanks.